Hello students, before continuing the session of the polynomials, I would like to clarify some of your doubts. Some of your friends had doubts, they had sent mail. Doubts related to the first chapter, real numbers. Srinivas Malipatil was having this doubt. In this particular question, there was a mistake. This is a by b, this one is a plus 2b by a plus b. In the question, it was a minus 2b by a plus b, which is not correct. This is a plus 2b by a plus b. Now how do we solve this? The meaning of root 2 lying between a by b and a plus 2b by a plus b is either a by b is greater than a plus 2b by a plus b, or a plus 2b by a plus b is greater than a by b. Let me say that this is case 1 and this one as case 2. Let me take one of the case 1. If you understand this, easily you will be able to solve for case 2. In case 1, I have taken a by b greater than a plus 2b by a plus b. Suppose if I transpose this a plus 2b by a plus b to the left hand side, it becomes minus of a plus 2b upon a plus b, which is greater than 0. Take LCM. On taking LCM, it becomes a square plus ab minus ab minus 2b square upon b times a plus b greater than 0. Here we have positive ab and negative ab, they get cancelled. We will be getting the result as a square minus 2b square upon b times of a plus b greater than 0. If you cross multiply, it becomes a square minus 2b square greater than 0. Once again, if you transpose this minus 2b square to right hand side, we get a square greater than positive 2b square. The reason why they have given a and b are two positive integers is, for this, if you take root on both the sides, we should be having a positive number, then only we'll get a real number. So root of a square is a greater than root of 2 is root 2, root of b square is b. So we got the result as a by b greater than root 2. Here in the first case, I was having a by b greater than a plus 2b by a plus b. The meaning is a by b is greater than root 2, greater than a plus 2b by a plus b. This is the meaning. Now I have done this part, a by b greater than root 2. Now I have to continue further and show that root 2 is greater than a plus 2b by a plus b. I will continue with this result obtained here. I'll take this step. Take a greater than root 2b. Square on both the sides. We get a square greater than 2b square. Let us do some tricks here. let me add a square on both sides. If you add a square, it becomes 2a square greater than a square plus 2b square. Let me now add 2b square on both sides. We get 2a square plus 2b square greater than a square plus 4b square. Further, I will add 4ab on both sides. If you do that, we get 2a square plus 2b square plus 4ab greater than a square plus 4b square plus 4ab. Look at this left hand side. We have 2 common. If 2 is taken common, it turns out to be a square plus b square plus 2ab, nothing but 2 times a plus b whole square greater than. Now look at the right hand side. We have got a square term here, a square. This second term is also a square term, it's 2b whole square. This 4ab is same as 2 multiplied to a multiplied to 2b. So I can write this as a plus 2b whole square. Now take root on both the sides. Square root on both sides. We get root 2 times of a plus b greater than a plus 2b. Therefore, root 2 is greater than a plus 2b upon a plus b. So I have got the next part also. Root 2 is greater than a plus 2b upon a plus b. Therefore, this result is obtained. So I can conclude that the value of root 2 lies between a by b and a plus 2b upon a plus b. Sagar Mudiwalar was having a doubt in exercise 1.1 question 9. His doubt was, why did I take the LCM of 6, 7, 8, 9, 10 only? Why not from 1 onwards? You just observe, we get the same result if you take only 6, 7, 8, 9, 10, or if you take right from 1 to 10, the LCM will remain same. Suppose if I consider 6, 7, 8, 9, 10 only, it is divisible by 2 3 times, 7 as it is, 2 4 times, 9 as it is, 2 5 times. Now once again it is divisible by 2. So 3 as it is, 7 as it is, 2 times, 9 as it is, 5 as it is. Now once again 2. Rest of the numbers we have to write as it is. Then it is divided by 3, 3 1 time, 7 as it is, 1, 3 3 times, 5 as it is. Once again I'll consider like this. Now I'll divide by 5. So what is the LCM in this? LCM is 2 cube multiplied to 3 square multiplied to 5 into 7. Suppose if I consider the numbers right from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. If you find the LCM, follow the same procedure. divide by the least prime number. Rest of the numbers write as it is. 2 times, 3 times is 6, 4 times is 8, 9 as it is, 5 times. Once again, let me divide by 2. The number which is not divisible, I have to carry forward. Now I will have to divide by 3. Here it is 3 times. So 1 1 1 1 5 1 7 1 1 time and 5. Now it is divided by 5. The rest of the numbers are written as it is. So 7 1 time, rest of the numbers are 1. This is how we are finding the LCM. Yeah. Look at this LCM. Yes. LCM is 2 cube multiplied to 3 square multiplied to 5 multiplied to 7. So we are having the same result. If you consider right from 6 onwards or from 1 to 10, we get the same result. The reason why I didn't take is, since 6 is a multiple of 2 and 3, 6 can be expressed as 2 into 3, and 2 and 3 will come there. Two of your friends had a doubt, should we have to write the notes along with the videos or just we have to watch the video? Listen friends, it is related to maths, and only by listening or only by viewing you will not be able to understand it. So best thing is to write and practice. These are the questions from NCERT exemplar, and also some of the higher, harder thinking skills questions. So the best thing to learn maths in class 10th is to practice. More the questions you practice, more you will be perfect. One more friend of you was having a doubt, why did I take these symbols alpha, beta and gamma? Why did I consider only this? Why not something else? There's no problem in taking any symbol for the zeros of polynomial. I have taken this basically for making it a similar type compared to other books. In most of the books related to class 10th, we have these symbols used. These symbols are only used. To maintain that, I have also taken alpha, beta and gamma. You can cross check in your textbook or RD Sharma or together with maths, we have these symbols taken. So to maintain the similarity, I have used the same symbols. Naveen and Abhishek Deshmukh, they had a doubt why some of the videos are not coming. Probably you must be using this digital classroom in your SSBJ website, ssbj.in. Sometimes, suppose say today is 12th, I want the video of say 9th. will I be able to access this? Yes, you will be able to access, provided you must subscribe the YouTube channel of our school. Then the videos which are uploaded in our YouTube channel, SSBJ YouTube channel, you will be able to access it. Suppose some teacher has done it in his own private channel, you have to actually subscribe that particular individual's YouTube channel. Then only you will be able to go back and watch the previous videos. If you have any doubt and all, you can always go back and watch it again. Whenever you are practicing maths, I suggest you pause the video, solve it on your own, understand why it is written like that. When you reason out, you will be understanding much better. Now we shall continue the polynomials. In the previous session we had completed exercise 2.1. Let us take up 2.2. Answer the following and justify. First one is, can x square minus 1 be the quotient on division of x raised to the power 6 plus 2x cube plus x minus 1 by a polynomial of degree 5? No. What is the reason? Suppose if you divide a polynomial by another polynomial, we have to actually look into the degree of the polynomial. In this, the polynomial has got degree 6 and the divisor has got a degree 5. So on division, quotient will be having the degree 6 minus 5, which is equal to 1. So x square minus 1 cannot be the quotient on division of the given polynomial x to the power 6 plus 2x cube plus x minus 1 divided by a polynomial of degree 5. Let's take second question. What will be the quotient and remainder be on division of ax square plus bx plus c by px cube plus qx square plus rx plus s, where p not equal to 0. Once again, observe the given polynomial is ax square plus bx plus c. For this, the degree is 2. The divisor, the other polynomial, is px cube plus qx square plus rx plus s. In this, the degree is 3. Whenever p of x degree is greater than the degree of the divisor g of x, then only the division is possible. In this case, can we divide? We can't divide it. So division itself is not possible. So what will be the quotient? There can't be any quotient. Degree of p of x is smaller compared to the degree of g of x. Which implies division not possible. When the division is not possible, there is no question of quotient. Still, if you want to divide this, there is only one option: px cube plus qx square plus rx plus s divide ax square plus bx plus c. We have to multiply 0, then we will be getting the same remainder p of x itself is the remainder. This is the only possibility. Otherwise, the division is not possible. Only we have to multiply with 0. Have a look at question 3. If on division of a polynomial p of x by another polynomial g of x, the quotient is 0, what relation between degree of p of x and g of x? What is the relation? This can be answered with the previous result when p of x is divided by g of x, and if the quotient obtained is 0, then the remainder is the given polynomial. They have asked what is the relation between these two. The relation is degree of p of x lesser or smaller than the degree of g of x. This is the relation. Look at question 4. If on division of a non-zero polynomial p of x by a polynomial g of x, the remainder is 0, what relation between the degrees of p of x and g of x? And once again, it is of the same type. If the remainder is 0 on dividing p of x by g of x, the remainder is 0. So it means we will get p of x here, the product of q of x and g of x will get the given polynomial p of x. It means that the relation is the degree of g of x is lesser than or equal to degree of p of x. This is the relation. Look at question 5. Can the quadratic polynomial x square plus kx plus k have equal zeros for some odd integer k greater than 1? The given polynomial is x square plus kx plus k. Since they have given that equal zeros, so let equal zeros be alpha and alpha. We have learned a relation, sum and the product. The sum of the zeros, in this case alpha plus alpha, is minus b by a. It becomes minus k by 1, nothing but minus k. So 2 times of alpha we get as minus k. Alpha is minus k upon 2. Let me call this as equation 1. Now let us take the product alpha into alpha, which is c by a. Here the constant term is k and the coefficient of x square is 1. So alpha square we get it as k. So let me take this as equation 2. In the place of alpha, let me substitute minus k by 2. So we get minus k by 2 whole square equal to k. This is from 1. I have substituted alpha value as minus k by 2. On simplifying, we get k square upon 4 equal to k. Cross multiply, we get k square equal to 4 times k. So it can be simplified as k square minus 4k equal to 0. K can be taken common, so we get k times of k minus 4 equal to 0, which implies the value of k is 0 or else the value of k is 4. Therefore, the quadratic polynomial x square plus kx plus k will have equal zeros for k equal to 0 or greater than 0. In this question we have k greater than 1. Therefore, the answer is no. Let us solve few questions related to true or false. Look at the first one in true or false. If the zeros of quadratic polynomial ax square plus bx plus c are both positive, then a, b and c all will have the same sign. The given polynomial is ax square plus bx plus c. Since it is a quadratic polynomial, let alpha and beta are the zeros. The zeros are both positive. What does it mean? It means alpha and beta, both the values are greater than 0. So what will be the sum? Sum of the zeros, alpha plus beta, which is minus b by a minus coefficient of x by coefficient of x square. It becomes a positive value. Therefore, a and b have opposite signs because the product of two negatives is positive. Therefore, this particular statement is false. Look at the next statement. If the graph of a polynomial intersects the x-axis at only one point, it cannot be quadratic polynomial. This particular statement is false. We have seen many examples. Let me take one of them. The graph of the quadratic polynomial, if it is of this type, will be having coincident zeros. It means both alpha alpha or both beta beta will be having equal zeros for this type of a quadratic polynomial. Therefore, if the graph of polynomial intersects at x-axis at only one point, still it can be a graph for a quadratic polynomial. Look at the next statement, the third one. If the graph of a polynomial intersects the x-axis at exactly 2 points, it need not be a quadratic polynomial. Let me continue the previous example. Let me take the same type of graph. So they are coinciding at this particular point. If this graph is continued like this, we will be having 3 points. Here there are 2 coincident points and one more point. Therefore, we can conclude that the graph of a polynomial intersects x-axis exactly at 2 points need not be a quadratic polynomial. It can be a cubic or biquadratic. It can be of any degree. So this statement is a true statement. The fourth statement, if 2 of the zeros of a cubic polynomial are 0, then it does not have a linear and a constant terms. Let us not come to a conclusion of saying whether it is true or false. For that, let's try to understand the two of the zeros of a cubic polynomial are 0. Since it is a cubic polynomial, let me take alpha, beta and gamma are zeros. According to the statement, there are 3 zeros, out of which 2 of them are 0. Let me take beta value as 0 and gamma value as 0. What will be the sum of the product of two zeros taken together, alpha beta plus beta gamma plus alpha gamma? This will be c by a for a polynomial of type ax cube plus bx square plus cx plus b. I told you friends, when we take sum of the zeros, we have to take minus b by a. The next term, when we take sum of the product of two zeros taken at a time as a positive c by a, and the product of the zeros alpha, beta, gamma, we have to take it as negative b by a. So let me take this side, the product alpha, beta, gamma, alpha into beta into gamma as minus b by a. Substitute the value of beta and gamma as 0. What do we get? We get this term becoming 0. This term also becomes 0. We will be left out only with, no, we will not be left out with any of this number here. The left hand side completely becomes 0. So this means that c value is 0. What about the product? Alpha multiplied to 0 multiplied to 0 is 0. So 0 is minus b by a, which implies b also is 0. Therefore, given polynomial does not have linear and constant term. Since cx plus d is not there, we'll have no linear or constant term. So this statement is true. Let us have a look at fifth statement. If all the zeros of cubic polynomial are negative, then all the coefficients and constant term of polynomial have the same sign. All the zeros, since it is a cubic polynomial, let me take alpha, beta, gamma. These are all negative, so it is less than 0. What will be the sum of the zeros? Alpha plus beta plus gamma is minus b by a. It is a negative value. Therefore, a and b have same sign. If you take alpha beta plus beta gamma plus alpha gamma is c by a, value is positive, which means a and b both have same sign. Let me take the product of the zeros alpha, beta into gamma. It is minus b by a. The value is negative. So what does it mean? It means a and d have same sign. Correction, this is c. A and c have same sign. Here a and d have same sign. So it means that our given statement is true. which implies A, B, C and D will have same sign. Let us take the next statement. If all three zeros are cubic polynomial, x cube plus ax square minus bx plus c are positive, then at least one of A, B and C is non-negative. The given cubic polynomial is x cube plus ax square minus bx plus c. The zeros are positive since it is a cubic polynomial, and if three zeros, say alpha, beta, gamma, they are greater than 0. Have a look at sum of the zeros, alpha plus beta plus gamma. It is negative of coefficient of x square by coefficient of x cube, so it is minus a. If you have a positive value, if the zeros are positive values, it means A is lesser than 0. Let me take product alpha beta into gamma. Alpha beta into gamma is negative constant term upon the coefficient of x cube, which is minus c by 1. Therefore, if you want a positive value, the value of c must be less than 0. Let me take the sum of the product of two zeros at a time. Alpha beta plus beta gamma plus alpha gamma. This is the coefficient of x by the coefficient of x cube, which is a negative b. To get the positive value, the value of b has to be less than 0. Therefore, you can say that the given statement is a false statement, because in each of these cases, consider the sum, product and sum of two zeros at a time, we are getting the value less than 0. Let's look at the last statement. The value of k for which the quadratic polynomial kx square plus x plus k has equal zeros is 1 by 2. The given quadratic polynomial is kx square plus x plus k. Since the values are equal zeros, let me take zeros as alpha and alpha. What is the product of the zeros? Product of the zeros is constant term upon the coefficient of x square. So k upon k, which will get cancelled. We get alpha square as 1. If alpha square is 1, the value of alpha is plus or minus 1. Since the roots are either positive 1 or negative 1, the given statement is false. These were few questions of exercise 2.2. In our next session, we will be solving exercise 2.3.